That is a tornado.
There it is, on the ground.
Oh my gosh.
March 21st, 2022.
You start seeing all the shingles getting sucked up into the sky.
There's just all of a sudden just like this wave of energy just hitting the house.
Multiple tornadoes ripped through central Texas, hitting Granger, Elgin, and Round Rock. Up to 400 homes were damaged in Round Rock alone.
Watch the porch that was here just take off.
Less than a month later.
The unpredictability of tornado season here in central Texas can lead to this. People living here on the border of Bell and Williamson counties now dealing with the aftermath of a tornado just weeks after tornadoes touched down not far from here.
Any structure, any tree, any piece of property that was in its path was damaged severely.
A lot of trees and churches and houses and mobile homes not there no more. And they're all gone.
Bringing up memories of the devastating Gerald tornado of 1997, the last confirmed EF5 tornado in the state of Texas. That killed 27 people and destroyed more than 40 homes. And almost exactly 100 years ago to the day, the Austin twin tornadoes swept through the city center, leaving behind this iconic image of the Capitol in the storm's shadow. Fast forward a century, tornado recovery is underway in multiple communities surrounding Austin.
We don't want to quit. We're not going to quit.
With a long road ahead for survivors.
At 75 years old, and my wife's 70, how do we start over?
All right, here to break down how these tornadoes form is meteorologist Carlo Falco. Carlo, let's just start with the very basics. What are the key ingredients to form a tornado?
Well, the number one thing you need for a tornado is you need a thunderstorm. That's the basic thing there. And for that to form, you need warm, humid air. You need a forcing mechanism, which normally is a cold front, but can also be a dry line. And you need cool air, dry air at the mid and upper levels of the atmosphere. Once that gets going, you can get what's called an updraft, which is the air from the surface rising up into the upper levels of the atmosphere. And then crucially, what you need from that to go into a tornado is you need that thunderstorm to start to rotate. What that happens is when you get what's called wind shear, which is when the wind, say at the surface of is blowing from the south, but at the middle levels of the atmosphere is blowing from the west. So that will give you kind of a rotation like this, and that starts the thunderstorm rotating, and that's called a supercell thunderstorm.
So is that criteria essentially what you look for to spot these potential tornadoes ahead of time?
Yeah, the wind shear, especially the directional wind shear, is a big part of what we're looking for basically forecasting when these tornadoes are going to be possible. But tornadoes on the ground, that is a much more difficult thing for us to spot.
Yeah, how do you spot those on the radar? What do they even look like?
Well, spotting them on the radar is very, very complicated. Basically, what you're looking for is what's called a TVS, or a tornado vortex signature. You can see it right here. It's those greens right up next to the reds on radar. So this is a velocity image of the radar. Doppler radar uses the Doppler effect, which is a complex physical phenomena of electromagnetism, to basically measure the wind speed in the atmosphere. And when you get those greens and reds right up next to each other, that means that the wind is moving very, very quickly in opposite directions, and that's an indication of rotation. In addition, you can see that right there. That is what's called a textbook supercell radar presence, with the area indicated by that blue arrow. That is a debris ball, so that is crucially what we look for as well. We can also look for what's called a correlation coefficient hole, which is the radar measuring the different particles in the atmosphere. Rain is all about the same size particle, but once you get a tornado lofting up debris like pieces of branches or, God forbid, pieces of houses, that's when the correlation coefficient, basically the different particles in the atmosphere, can get very, very different, and it shows us as a much darker color than what normally would show.
And finally, most people are familiar with the EF scale. Essentially, it shows us the magnitude of these tornadoes, but how do you come up with that scale, or how do you come up with the EF number?
Well, that's what the National Weather Service does after there's a confirmed tornado. They go out and they do what's called a storm survey, and they look for the damage to approximate the wind speed. So an EF0 would be a 65 to about 85 mile per hour wind. That is still can cause some significant damage, but is not considered a strong tornado. That's a weak tornado. EF1s, you're getting a little bit stronger, up to about 110 mile per hour winds. EF2s are starting to get into the strong category with up to 135 mile per hour winds. These are the tornadoes which start to snap trees in half. An EF3 tornado can rip trees out of the ground, toss cars around, and create winds up to about 165 miles per hour. EF4 tornadoes are the really dangerous ones. EF5s, of course, are stronger than that, with winds up to about 166 to 200 miles per hour. As these winds blow through everything, they can entirely destroy and demolish entire communities.
All right. Thank you so much for breaking that down for us, Carlo.